Okay, this is just the first couple problems on today's notes page since I didn't get a chance to go over them in class. Um, Let theta be an acute angle such that sine of theta equals 0.6. Find the values of first cosine theta and then B tangent theta using trig identities. So for part A, to find the value of cosine theta, I'm going to use that Pythagorean identity that was listed towards the top of your page. So it says sine squared plus cosine squared equals 1. If sine is 0.6, I'm going to put 0.6 squared plus cosine squared theta equals 1. 0.6 squared is actually 0.36, sorry. So plus cosine squared theta equals 1. I'd subtract my 0.36 over. So I have cosine squared theta equals 0.64. When I square root both sides, I'm going to get that cosine of theta equals 0.8. And that's what I wanted to know, was what is cosine of theta. On B, now that I know sine and cosine, I can use my quotient identities to find tangent. So it says tangent is sine divided by cosine. So sine is 0.6, cosine is 0.8. So 0.6 divided by 0.8 is just 0.75. So that's my tangent of theta. On 2, we're using those trig identities and try to transform one side into the other. So all I'm doing is messing with one side. I'm not moving stuff from one side over to the other. So when I look at cosine and secant, I know that secant is actually, according to my reciprocal identities, 1 over cosine. So on the left side, I really have cosine of theta times 1 over cosine of theta. Cosine of theta times 1 over cosine of theta is just 1. So now I have 1 equals 1, which is what I wanted. Yes, you need the check, and yes, they need to say the exact same thing. You cannot stop at this preview part. I am changing the left side completely until it equals the exact same thing as the right side, like saying the exact same thing. Over here on B, secant theta plus tangent theta times secant theta minus tangent theta. When I multiply those out, and I can just think of if you were doing like x plus 3 times x minus 3, that's going to turn into your difference of two squareds, x squared minus 9. So the same thing here, or I could FOIL it out, which is fine. I'm just showing you a possible shortcut. So I'm going to end up with secant squared theta minus tangent squared theta equals 1. If you look at your Pythagorean identities, secant squared, it says, is actually the same thing as 1 plus tangent squared. So I'm going to replace that with 1 plus tangent squared theta, and then minus tangent squared theta equals 1. 1 plus tangent squared theta minus tangent squared theta. Tangent squared minus tangent squared is going to cancel. So I'm going to have 1 equals 1. And that's it. Make sure you have the rest of this finished tonight.